This video is going to focus on the basics of vectors. So a little bit on 1D vectors, a little bit on 2D vectors, not really yet focusing on quantitatively working on vectors, but working with them in a conceptual or graphical way, which will be really important for working with motion diagrams. Now there are two big student learning outcomes that this connects with. One is the idea of creating representations, of how you can actually represent physical situations, and the second is communicating them. So when we're talking about vectors, we need to be intentional in how we're communicating these quantities and what they actually mean. So the basics of a vector is that it is going to look like an arrow, and it has a length, which is going to represent its magnitude, and it's going to have a direction, which is just where the arrow points. So if you haven't seen a vector before, in this class we're going to be representing vectors with arrows, and when you draw them, they should look also like arrows in that they need to have a tail and they need to have a tip, where the tail is just where it starts, the end without the arrowhead, and the tip will be the end with the arrowhead. Now, vectors are always going to represent specific quantities in here, so specific physical quantities. In this case, this is actually a displacement vector. Now note that it's been labeled, and if you haven't watched the notation videos, you might want to go back if this is new to you, that this triangle is the delta representing change, and in this case we see that this is an R, which gets used to mean displacement or position, and that we have subscripts, since in fact we have 4 different displacement vectors here. Now the fact that it's a vector means that this variable needs to have that little arrowhead, meaning that it's a vector. So we've labeled what our vectors are, with in this case a variable, since they correspond to very specific quantities. So briefly, I want to talk a little bit about the difference between a position vector and a displacement vector. It might seem like we could use those interchangeably, but within a physics context, they actually have a very different meaning. So if you have an object moving, in this case we're representing its motion on a plot where we have 2 dimensions, a y-axis and the x-axis, both representing position, that we can see these black dots represent its position at different points in time. The position vector is the vector that goes from the origin to the position that it was at. So each of these arrows are the position vectors, where we're naming them as the R vector, meaning position, with a subscript of 3 and then 4, meaning that this was the 3rd moment in time, which happens to be 3 seconds, and then the 4th moment in time, which happened to be 4 seconds. So the position vector goes from origin to the position. The displacement vector is actually the difference between positions. How did you move from the 3rd position to the 4th position? So it also is going to use the letter R in this case because it relates to position, but now that delta appears, meaning a change. So this is the change in position here. So note that it doesn't actually relate to the origin, it doesn't come from the origin, but it goes from 3 to 4. So that's the difference between position and displacement vectors. Now 2 other types of vectors that we're going to see right away are velocity vectors and acceleration vectors. And in later talks, we'll understand more about how to actually calculate these and use these, but at least right now it's important to understand that velocity is speed with a direction, and acceleration is going to be how that velocity is changing.